Orbiting a faint ruby-red sun just 40 light-years from Earth lies a remarkable planetary system. 7 rocky worlds circle close to their star, each roughly the size of our own planet. Astronomers have studied this cosmic family, the TRAPPIST-1 system, for years, searching for clues about which, if any, might be more than just Earth's lookalikes. Could one hide an atmosphere rich in water vapor, oxygen, or carbon dioxide? Could there be a place where rain falls, rivers flow, and life itself takes hold? The quest to answer these questions has ignited the imagination of scientists and dreamers alike. TRAPPIST-1 is a tantalizing target, a compact system with not just 1, but 7 rocky planets, 3 of which orbit within the so-called habitable zone, where temperatures could allow liquid water to pool on the surface. For a time, hope soared that we might be on the cusp of finding an Earth twin, a second home in the cosmos. But the universe seldom yields its secrets easily. Now, the latest observations from the James Webb Space Telescope, our most powerful eye in the sky, have delivered a sobering update. The third planet from this dim red star, TRAPPIST-1d, once a promising candidate for habitability, shows no sign of an Earth-like atmosphere. The dream of a blue sky and gentle breezes on this exoplanet has, for now, been set aside. How did astronomers reach this conclusion? It all comes down to the extraordinary sensitivity of the James Webb Space Telescope, or JWST. Unlike any telescope before it, JWST can peer across the light years and actually study the atmospheres of distant worlds as they pass in front of their stars. During these transits, a tiny fraction of the starlight filters through the planet's atmosphere, if it has one, imprinting the chemical fingerprints of molecules like water vapor, methane, and carbon dioxide onto the light that eventually reaches us. This technique, known as transmission spectroscopy, is a powerful tool. By splitting the starlight into its component colors, astronomers can detect the telltale absorption patterns of various gases. In the case of TRAPPIST-1d, teams led by Caroline Piolet-Gorayev at the University of Chicago and the Trotter Institute for Research on Exoplanets trained JWST's near-infrared spectrometer on the planet as it crossed in front of its star. They looked for the signatures of greenhouse gases, the very molecules that help trap warmth and create stable, life-friendly climates on planets like Earth. But the result was clear. TRAPPIST-1d appears to lack those crucial atmospheric markers. No evidence surfaced for water vapor, methane, or carbon dioxide, the chemical ingredients that play a vital role in making a planet habitable. This absence doesn't just dim the prospects for life on TRAPPIST-1d, it also highlights the challenges faced by planets orbiting red dwarfs. Why is it so difficult for these worlds to hold on to an atmosphere? The answer lies with their star. Red dwarfs, while small and cool compared to our Sun, are anything but tranquil. They frequently unleash powerful flares and bursts of radiation, especially in their youth. These energetic outbursts can strip away a planet's atmosphere over time, molecule by molecule, leaving behind a bare, rocky surface. It's possible that this fate has already befallen not just TRAPPIST-1d, but also its 2 inner neighbors, TRAPPIST-1b and TRAPPIST-1c, which also show no sign of atmospheres in JWST's data. Of course, science rarely deals in absolutes. There are still a few possible explanations for what JWST found or didn't find. TRAPPIST-1d might possess an extremely thin atmosphere, similar to what we see on Mars, making it difficult to detect from so far away. Alternatively, it could be cloaked in thick, high-altitude clouds that obscure the spectral fingerprints of atmospheric gases, much like Venus in our own solar system. Or it could be utterly barren, a silent, airless rock orbiting a restless star. The loss of TRAPPIST-1d as an Earth-like candidate is a disappointment, but the story is far from over. The TRAPPIST-1 system still contains 4 more planets, some of which lie squarely in the habitable zone. In fact, Planets E and F orbit in the region where conditions could be just right for liquid water, provided they can hold on to an atmosphere. Planet G sits at the outer edge of this zone, somewhat like Mars in our solar system, while Planet H, furthest from the star, is almost certainly too cold for habitability as we know it. Yet probing these outer worlds presents its own set of challenges. As their distance from the star increases, the signature of any atmosphere becomes fainter, more elusive, perhaps even beyond the reach of JWST's extraordinary instruments. Detecting these subtle signals may require even more sensitive telescopes or new techniques. Yet probing these outer worlds presents its own set of challenges. As their distance from the star increases, the signature of any atmosphere becomes fainter, more elusive, perhaps even beyond the reach of JWST's extraordinary instruments. Detecting these subtle signals may require even more sensitive telescopes or new techniques, but the pursuit continues. Despite the setbacks, the search for a truly Earth-like world goes on. The universe is vast, and TRAPPIST-1 is just one of many red dwarf systems in our galaxy. In fact, red dwarfs make up about 3/4 of all the stars in the Milky Way, and the inventory of potentially habitable exoplanets is only growing. Other intriguing targets like Teegarden Star B, LHS 1140b, and Proxima Centauri b beckon astronomers to keep searching, keep asking, and keep dreaming. And on the horizon, new missions like the European Space Agency's PLATO, set to launch in the coming years, promise to accelerate the search for habitable worlds around sun-like stars, expanding the boundaries of what we can find and understand. The cosmos is a place of wonder and surprises. Each new discovery, whether triumphant or sobering, brings us one step closer to answering the fundamental question: are we alone? For now, the story of the TRAPPIST-1 system continues to unfold, shaped by data, driven by curiosity, and illuminated by the light of distant alien suns. Astronomers had long hoped that TRAPPIST-1d might be a prime candidate for an Earth-like world, a potential twin or cousin to our own blue planet. But with the latest data from the James Webb Space Telescope, that prospect has faded. JWST's powerful near-infrared spectrometer, NIRSPEC, searched for the chemical fingerprints of water, methane, and carbon dioxide as TRAPPIST-1d passed in front of its cool, red host star. Yet the observations revealed no telltale signs of these vital atmospheric components. For now, TRAPPIST-1d has been struck from the list of likely Earth analogs. This is not the first disappointment in the TRAPPIST-1 system. Earlier observations had already ruled out substantial atmospheres for both TRAPPIST-1b and c, the two closest planets to the star. Now, with TRAPPIST-1d joining their ranks, the dream of a temperate, watery world around this diminutive red dwarf seems increasingly out of reach, at least for the system's inner planets. The culprit behind these barren outcomes may be the very nature of red dwarf stars themselves. Though small and cool, these stars are anything but gentle. Red dwarfs are notorious for their frequent and violent outbursts of high-energy radiation. Over time, these flares unleash enough power to strip a planet's atmosphere away, molecule by molecule, leaving behind a desolate, rocky core. TRAPPIST-1d orbits near the system's inner edge of the habitable zone, similar to where Venus sits in our own solar system, a location that is theoretically warm enough for liquid water, but also dangerously close to the star's wrathful emissions. Still, the story is far from over. 4 more worlds remain in the TRAPPIST-1 system, with planets E and F positioned squarely in the star's habitable zone. Planet G, a bit farther out, might resemble Mars in our solar system, cold, but perhaps not entirely inhospitable. Even Planet H, though likely too far and frigid for familiar life, adds to the intrigue of this remarkable cosmic lineup. The challenge for astronomers now is that, as these planets orbit farther from their star, any atmospheric signatures become weaker and harder to detect. Even with the unmatched sensitivity of JWST, the signals may be so faint that they slip beneath the threshold of our instruments. Yet hope persists. While TRAPPIST-1d lacks a thick, detectable atmosphere, it's possible that the outer planets hold on to theirs more tightly, shielded somewhat by their greater distance from the star's punishing flares. If these planets possess dense clouds or significant greenhouse gases, they might trap enough warmth to allow for the presence of liquid water, one of the essential ingredients for life as we know it. The search for these subtle clues continues, and each observation refines our understanding of what makes a planet truly habitable. Even if all 7 worlds of TRAPPIST-1 ultimately prove barren, the broader cosmic context offers endless possibilities. Red dwarfs make up more than 75% of all stars in the Milky Way, and astronomers have already found intriguing candidates orbiting other nearby red dwarfs. Teegarden's Star B, LHS 1140b, and Proxima Centauri b, though different in their own ways, illustrate the diversity and abundance of rocky planets throughout our galaxy. And while many of these worlds face the same challenges from their tempestuous parent stars, each new discovery teaches us more about where to look, what to look for, and how to interpret the signals we receive. The search is not limited to red dwarfs alone. Scientists eagerly anticipate the launch of new missions, including the European Space Agency's PLATO, currently scheduled for late 2026. PLATO will focus on finding rocky exoplanets in the habitable zones of sun-like stars, where conditions may more closely resemble those on Earth. With every new telescope and mission, our reach extends farther, and the catalog of potential Earth analogs grows larger. The ongoing investigation of TRAPPIST-1 and its planetary system is a testament to the power of modern astronomy and the relentless curiosity that drives us. Each observation, each data point, brings us a step closer to understanding the complex interplay between stars and planets, atmospheres and radiation, hope and reality. The quest to find another Earth is as much about refining our questions as it is about chasing answers. What makes a planet habitable? Can life emerge and endure in the shadow of a volatile red dwarf? Or must we look elsewhere, to quieter suns and more temperate skies? As we await the next observations and discoveries, one thing is certain: the universe remains rich with possibility. TRAPPIST-1 may not have yielded an Earth twin yet, but the search is only just beginning, and new worlds await our exploration. The cosmic ocean is vast, and with each new mission, we cast our nets wider, hoping to catch that one gleaming planet that feels like home. If you enjoyed this deep dive into the TRAPPIST-1 system and the search for habitable worlds beyond our solar system, make sure to like this video and subscribe for more content like this.